Okay, so we're really pleased to welcome everyone to the CTSI's first installment in our series of Team Science. I'm Julie Lockman, Director of Investigator Development and Professional Development for the CTSI. Our institute consists of partner sites across the state of West Virginia, and our programming on Team Science is being developed by Dr. Darshana Shah of Marshall University. Following up on this webinar will be another webinar by Dr. Shah taking place on December 8th at noon, and then a workshop to focus on practical applied skills as a team member or a team leader will follow in the spring. And regarding that, we currently have a needs assessment survey that is live to gain input from CTSI membership as we move forward in developing the workshop, and we encourage those of you watching and listening to complete that. It was actually sent out to all our membership on October 31st as a special announcement, and it's also mentioned in the CTSI e-news that was sent out yesterday, November 9th. So we hope you'll participate in the survey. It will remain open for a couple more days, and maybe this seminar today will strike some additional thoughts that you might have for feedback in that survey. And so that's just kind of a little bit of an introduction here. And now I'm pleased to introduce our speaker for today, Dr. Darshana Shah. She is an enthusiastic and valued member of the CTSI Professional Development Corps, where she serves as one of the site coordinators at Marshall University. Dr. Shah is a professor of pathology and associate dean for the Office of Faculty Affairs and Professional Development at the Marshall University Joan C. Edwards School of Medicine, where she has been a member of the faculty since 1997. Her passion for service has led her to attain diverse institutional roles, notably serving as founding editor-in-chief of the Marshall Journal of Medicine, a peer-reviewed journal published by Marshall University's School of Medicine. She has a strong record of achievement and leadership highlighted by creation of an outstanding multi-tier comprehensive faculty affairs and professional development office that provides numerous tailored programs for mentoring, teaching, and leadership. Dr. Shah embodies a servant leadership model, a fact well demonstrated by her many active leadership roles within local and national organizations. She's been actively involved in the AAMC group on faculty affairs for the past 10 years. She served as a member at large on the Group on Faculty Affairs Steering Committee since 2013 and was elected chair in 2015. Dr. Shah's leadership is built on a foundation of collaboration, allowing her to establish and maintain meaningful partnerships that result in demonstrated success. Additionally, she is the first Marshall University faculty member selected as an Executive Leadership and Academic Medicine Fellow, that is the ELAM program, completing that program in 2010. She's now an ELAM Learning Community Faculty Advisor. Dr. Shah has a passion for the topic of team science and has developed a course at Marshall University entitled The Fundamentals of Team Science, and we're honored to have her extend this educational opportunity to CTSI partners across the state. Dr. Shah, thank you very much.
Thank you, Julie, for your kind introduction. On behalf of West Virginia CTSI Professional Development Corps, I would also personally like to welcome you to our first Team Science webinar. For today, I have the topic of Team Science 101. I have actually, okay, my slides are not moving, sorry. Okay. So I have outlined today's topic on 3 core concepts of team science. We are going to go ahead and discuss basically what is team science, and also clarify the difference between what is team science and what is the science of team science. The second one, we will address why team science and why now. And the third, I would like to discuss foundational concept of how do you build an effective team. If you Google the word team, you will actually pull up thousands of acronyms for team and also several inspirational quotes about the team. Also word cloud listing the characteristic of team. The one you see right now on my slide, I've pulled out a couple of those. So team as an acronym is together, everyone achieves more. And inspirational quote by Pat Riley of great teamwork is the only way we create the breakthrough that define our careers. And you can see the word cloud, which basically lists everything or attributes to the teamwork, whether it's a performance, efficiency, collaboration, everything is actually falls under the teamwork. So the team science, or before we discuss the team science, I would like to highlight that the team practice is not a new concept. I mean, we probably practice ourselves in several arenas, and also several other industry, including the Air Force, military, even there is a rescue mission group, the sports team, and even hotel and culinary institute all have practice, team practice are very well known. The one which is we are all familiar with, the healthcare team, because that's the one has been practiced in common in healthcare service, healthcare research has been very well established. Institute of Medicine, I think you may, somebody's speaker is. So Institute of Medicine, National Academy of Science, I think they published several reports on healthcare team. They had talked about one came in 2003 and the most recent one in 2014, which actually putting healthcare teams in the system approach. But what I would like to highlight that regardless of the team in the healthcare team, as shown on your slide, they're all tied together with a common shared core value. And I think the one in the picture which I've shown and the reference is listed below, this is an autonomy, benefit of others, do no harm, and those are the core principle of the team, healthcare team, which they were trying to study the professional identity. The one in 2003, the core value for the healthcare team, they were all tied together based on honesty, humility, readiness for collaboration, and the discipline. And I think that just gave very good working dynamic for the health care teams and keeping patient in center. These core value can actually help function the team very effectively. So since we are talking about team science, I also wanted to bring to your attention that the concept of team science is not new. If you really research it out, it goes as far as 1793. And this was Antoine Lavoisier, who was a French chemist. And he's also known as a father of chemistry. In the history of chemistry, he was the one who contributed the name oxygen and hydrogen in 1783. And he's most noted for his discovery of role of oxygen in combustion. The few things I wanted to point out from his quote, and basically in 1700th century, he lists that the work is still need to be done in science. It is going to be precisely, we need knowledge and cooperation of many scientists and many disciplines. And you will also need, or there'll become a necessity where scientists and technologists in different disciplines will have to meet and work together. So even those times, the branches of knowledge which seems to have least relation connection with one another, but what he implicated that we really have to have working collaboratively, and this is where I think the concept of team science originated in 1793. Now, in last several decades, this kind of evolved. Of course, the first with the NIH commitment to team science, where NIH had actually published, and again, I've given the link, so you can definitely review the roadmap, where NIH, this came out, I think, in 2004. And there were 3 core themes, and I've just lifted the one, basically for the future of the research team in future. And in that, NIH has also listed that the scale and the complexity of today's biomedical research problem requires researchers to intellectually extend themselves beyond their area of research to create new collaborative science team and new scientific discipline. Research teams of the future are encouraged to combine skills and discipline in physical, biological, and social sciences, and the training of investigator and the development of novel support mechanism to facilitate this endeavor. So as I read this to you and showing you the slide from the 17th century, actually the message is pretty much the same. It's just that now it's surfaced more because now the funding agencies are putting this on us. So it is important for us to actually learn the new language of the team science. So what is team science? So if one has to define, it is an integration of two or more scientific approach to solve a complex, multifaceted problem. And it can also, you can also probably highlight the team science is a collaborative effort to address a scientific challenge, which basically will leverage the strength and expert of professional trained in a different field. And I think this is where the highlight becomes the team science. It's a collaborative approach, and that will actually be, as I move on with this presentation, this will hopefully become a lot clearer. Before I discuss more detail on team science, I would also like to highlight the terminology, the team science versus the science of team science. And I think these two terms are not synonymous. The team science gives, basically implicates the collaborative effort to address the scientific challenge, as I listed in my earlier slide. And the science of team science is actually another evolving interdisciplinary field that empirically examines the process by which how these teams are collaborating. So they are actually studying the scientific teams or the research center, institute, organize, how do they communicate, how do they conduct their research? And they are basically asking questions like what individual factor, what societal factor implicates this team. So this has become actually a new upcoming field, and that is just helping to apply the learning to the effectiveness of team science. So I'm going to review a few nomenclature of scientific teams, which you probably have already are aware of. But so one is the unidisciplinary team. So especially in clinical translation science, it is very, very important for us to have a clear understanding of this scientific team. So you have a unidisciplinary scientific team, which is a researcher from a single discipline work together to address a common research problem. So for example, you have a pharmacologist researcher, and then again, that's their discipline. And they are trying to study the relationship between nicotine consumption and insulin metabolism. So this is what one discipline, they may collaborate with other pharmacological lab to see researcher and on the similar problem. Then from unidisciplinary, we're going to go into multidisciplinary, which is a sequential process whereby researcher in different discipline work independently from his or her own discipline specific with the goal of eventually combining their effort to address a common research problem. So I'm going to again take the same example what I gave you earlier. So in this case, you have a pharmacologist, you have a health psychologist, and you have a neuroscientist. They're all working independently in their own area, but then they can have multi-authored manuscript, which will have which will review the research in the respective field pertaining to the link between nicotine consumption change in brain chemistry, calorie intake, and physical activity level. So that becomes a multidisciplinary team. The multidisciplinary to interdisciplinary, which is an interactive process in which the researcher works jointly, each drawing from his or her discipline, specific perspective to address the common research problem. So we can actually go ahead and use the similar example of the pharmacologist, health psychologist, or neuroscientist, and which will conduct collaborative study to examine the interrelationship among pattern of nicotine consumption, brain chemistry, caloric intake, research design, and incorporate conceptual and methodological drawn from each of their respective field. But once the project is over, they can basically go back into their own field. The transdisciplinary approach, or that's probably becoming now light for us, those of us who are involved in translational or clinical and translation science research. It is an integrative process. And there you can have the teams are actually synthesizing the product. So they work together, extend discipline-specific information to address a common research problem. And just to highlight, similarly in the example, that you can have, again, a pharmacologist, health psychologist, neuroscientist. They will actually come up with a collaborative study. Together, they are going to examine the interrelational relationship among consumption of nicotine, brain chemistry, caloric intake, physical activity level. But this work, what I had given you the example with earlier teams, they're actually going to set up an experiment together. They will actually have these extend methods. They are drawn from the respective field, and this can be led by several scientists, but they collaboratively work together to address the problem. So it was important for me to highlight the nomenclature of scientific team, and now actually I'm going to show you an example, just highlighting what I described in my earlier slide. So the scientific research team becomes a continuum. And in this slide, basically, I'm highlighting that based on the low to high interaction, level of interaction and integration decide how cohesive the scientific team is. So low interaction is, again, will be at the spectrum as shown here. I'm trying to pull out the pointer, bear with me. So it is shown to the low interaction. Basically, the investigator works on the scientific problem largely on his or her own. And now I think giving you the nomenclature, you probably saw that how it is important to probably make it more into integrated format. In a case of the intermediate level of interaction could be characterized by more than one multidisciplinary approach, where two or more researchers from different lab work project together, yet they are highly integrated. But in this scenario, each might bring his or her own specific integration or expertise, and then they will actually apply those expertise to the project, performing experiment and analyzing the data. And then once the work is completed, they may not continue to interact. The highly interactive research team is the one which works together. And they are the one, this group is actually led by one or more scientists, and it's composed of researchers from diverse background as listed on the slide. The collaborators will have developed common objectives, coordinated their resources, composed shared agenda, and activities directed towards achieving those objectives. So now I'm hoping I've been able to clarify the concept behind the team science, and each scientific team which follows those concepts are a highly integrated research team. And a couple of the slide, what I showed earlier, basically emphasizes that. So let's look at the why team science, or why now. And I think the next slide, what I'm trying to show you is basically the global base map of science. And the first thing is the driver. What are the drivers of team science? So now it has broadened the horizon. The biomedical scientists can no longer stay on the bench, but they can be joined now by engineers and other discipline. So the map here actually shows the nodes, the colored nodes represents the Web of Science category. And if I can highlight, you can have a biomedical scientist, chemistry, material science, mechanical engineering, physics. The gray links represents degree of cognitive similarities. So I think this also gives a very different perspective that you have now the science, it has broadened the horizon of the discipline which are pretty much related to science, and this map actually demonstrates that very well. Now research is increasingly conducted in teams across virtually all the field, and 90% of all work in science and engineering discipline is done in teams. And this has become pretty much of the norm. And as I said, that even though the concept is probably a decade old, but it is now evolving and really becoming the mainstream that researcher needs to be working in teams, and as very clearly shown by that. I would like to give an example, like how does this broadening the horizon and relatedness of the science discipline actually work whenever we try to do the research. So one of the example I have given here is the collaboration, and this is the system map of obesity. So there is an increasing realization that team science is needed to tackle or conquer the health problems that are plaguing our society. And we are in the time of obesity epidemic. And I think if you really look at the map, it just shows how many different disciplines this is integrated, or how many interaction of researchers could work together to conquer the epidemic of obesity. So just to give example that you can have, when you want to solve the obesity epidemic, most likely you will require to integrate interaction of researcher who actually study lipid metabolism, who study the genetics, who study the cell growth. Then since adding on to more teams, you may want to work with endocrinologist, pediatrician, internist, surgeons, exercise physiologist, nutritionist, behavior researcher, psychologist, and also economist. So these are just to name few types of specialty who can actually team together to conquer the epidemic of obesity. So I just thought the system map actually gives a pretty cool way to look at it, how many disciplines can be attached to the problem you're trying to work. And I think this highlights the nicer way to demonstrate, even though the whole issue of obesity, it is not just the problem of one discipline, but you have a interdisciplinary approach by several people involved to attack the obesity epidemic. I had just actually tried to summarize that to show that it is the different discipline can actually attack the epidemic, and just the things which I added may just give you a little bit of clarity instead of just the whole mash of the map. This might probably provide that so many things can work together, or so many disciplines are involved in attacking the problem. So why team science? We continue that, and why now? So as suggested earlier, that the complex 21st century societal problem, and this could be anything with the health, environment. Lately, we are also struggling with the natural disaster. Everything is actually going to require a team approach, and the team science brings the synergy among the team with the shared goal and the mission to conquer the problem you're working on. So it not only brings the synergy, but it also helps the team speed up the rate of discovery, because you have a multiple perspective that also brings multiple expertise of the team members. You can also apply novel methods to solve the old problem, apply any specialized knowledge to the new problem, and then promote the breadth of knowledge, because now it's not somebody working in a solo or isolation, but now this is a team approach. So team produces highly cited research and patent than the individual. So if one is trying to churn the wheel in its own siloed manner, it's going to be a lot more challenging versus the team working together to solve the problem. Wanted to highlight the geospatial map of publication co-occurrence. This was just in PLOS1 on Alzheimer disease. And basically what they have shown, this particular slide shows the team of researchers across the country, and just the map just shows that they all have to get working together to target the Alzheimer. And I think I'm actually have given the reference. So here I just wanted to show that it's a neuroimaging initiative the team has taken. And the second slide from the same paper shows that there is a growth of co-op publication network over the time. And from 2014 to 2015, the publication rate has increased because the entire team is working towards that. So this particular two slides basically just shows you an evidence of scholarly output. For more than that, the increase in breadth of knowledge are shown when the team science is effectively working. Now, the next couple of slides, I would like to show some of the hypotheses which actually been implemented and also proven that the team advantage of team-based research is a lot better than the solo individual research. And that again becomes unidisciplinary research. That's probably the phrase is the right phrase for me to use. So in this the slide, and most of my slides have references listed at the bottom, but I think you could definitely let us know, and any other information or detailed information you require towards some of the material I'm presenting, we'll be happy to provide that. So here on the one of the slide, in this one you have an generally whenever the innovation occurs, innovation does not happen in isolation, and I think that is already proven. Innovation is actually augmented through the teams. So generally whenever there is an innovation, there are a couple of phases the team will go through. So you have a variation, selection, and the retention. So variation phase where actually one can have an idea, and that idea can be maybe finding out some major breakthrough pattern, or this idea can be actually vetted. And whenever you have an individual idea versus the team idea, that idea is pretty much sustainable because the team will bring different perspective. They will actually discuss what will work, what will not work. And that idea is vetted enough, so the chances of that idea to have a complete failure is a lot less than the individual coming up with the idea and trying to make a breakthrough. So basically this hypothesis just shows that the team selected idea or basically which promotes for the innovation has longer term of retention, or it means the sustainability of that idea is a lot more than an individual or unidisciplinary approach. The second slide is pretty much also showing how valuable the diverse team is. And here we're talking about the diversity in terms of intelligence. So whenever you have the team with a shared mindset, think sequentially, and that's what is shown here. So the blue line is right here. So if you have all the pharmacologists working together, this is the homogeneous team, and their thinking pattern is pretty much going to be sequential, and they may create a standard solution. But when you bring the team from a different discipline, who bring the way they were trained, their specialty, they actually bring a little different perspective to the table. And generally, most of the time, the team with a diverse mindset will develop an idea as a member, learn new material, new connections are made, and ideas are enriched by each members and the team and their own network. So this just two hypothesis is actually now proven. And I think they have got a couple of examples when they've done with HIV, and I'm blanking out, but there are a couple of examples which I think have shown that how rapidly some of the solutions were brought into when people worked in team. I think one of them was the SAR syndrome. So far, I think I've discussed what is team science, and the reason it's important because the drivers are not only the funding agency who really want to see the resources distributed evenly, and also mainly the team working in a team. I think that probably is needed now because the 21st century, our challenges are also becoming more. We have more questions which we have not answered. So team building, teamwork, it should be easy, but it's not a rocket science. But still, why are we not having difficulty, or why are we having difficulty in forming a team? And that's the second part of my talk would be to look at those factors, that why the team building, even though it's not a rocket science, why it is difficult for the team to be successful. So giving you the nomenclature basically gives you a dimension of team science, and this table basically lists what are the different dimensions. So unidisciplinary and transdisciplinary. So you in heterogeneous components. So these are, as we listed earlier, people have their different way they were trained, their area of expertise, their area of training. They do bring a breadth to the team because not only the knowledge expertise, but just the way the training was done. So And just some of the examples. So I have two masters probably from India, and then came here and did my PhD. But the way the PhD students were trained here versus the graduate student were trained in India were very, very different. So I think you do bring those kind of knowledge also based on where you were trained. But when you put in a team, that approach is actually blended very differently. The teams are mega nowadays, I think, and just to show you the example, what we did for the PLS paper, they're large group. They may work in a smaller team, but the team size is variable. They are sometimes divergent or misaligned. A lot of time, the team and organizational boundary are very fluid. So it's very difficult to look at. That's another dimension it adds to the team science. And the team science is also the proximity of team or group members. So, I mean, we are all from West Virginia, but we are still, some of us on this call probably are maybe 2 to 3 hours away. Or the Eastern campus, if we look at the regional campus, is probably 5.5 hours away. But in this case, a lot of the teams are globally distributed. So that's another, it also adds another dimension. The task interdependence, when it becomes a heterogeneous team with the size and the distance and alignment, we really have to be highly dependent on each other. So those are the things probably add a little bit more complexity to the team science. And that is the reason I think sometimes the research team will succeed while others do not. So what I would like to highlight now next is what are the foundational concepts which will make the team science more effective. So if you look at the literature, again, the corporate world or the business world had adopted this way back. So if you look at some of the HBR article, or if you look at the Forbes article, they are always talking about the team, building team, working in team. And the literature has cited frequently team model, and I've listed them here. We won't have time today to go over this model, but as we continue to work together, we will probably go a little bit in depth about these models. So they had a model, the task-oriented team development model, Kaizenbang and Smith model of wisdom of team, when the team works best. And the one which leading teams are the Patrick Lencioni model of the 5 dysfunctional of a team. And I definitely recommend those of you who love to read, I think that's a pretty very nice read of the 5 dysfunction of the team. Maybe you may want to probably review that book. It's pretty nicely given. The last one I have added, because that is the one which is added actually into National Academy of Science published a book in 2015 on team science. And they have actually used the model of the Steve and Daniel for enhancing effectiveness of work group and team. So I just wanted to highlight some of these frequently cited team model. So whether you look at from 1977 model to 2006, which no matter which model you pick, there are significant similarity among these models. So basically, the one thing which ties together the team is the common purpose. And what is the purpose, what needs to be accomplished, or the team goal. So as I mentioned earlier to you about the healthcare team, they were bound together with the common core value, the purpose, and the goal, which kept the healthcare team together. They respected the hierarchy, the learning, the humility, and the slide which I showed. Basically, they were shared goal which bound them together to giving the best care. Now, another thing which was common, they found there are 2. One is trust, and the second is a teaming skill. The trust is also in truthful in communication, trust in action, trust inside the team. And there are several teaming skills which I've listed here, and we will probably go over that a little bit briefly in my next couple of slides. And I thought this schematic was pretty nicely given. The trust, communication, planning, adaptability, decision-making, problem solving. So regardless of the team you work in, whether it's a clinical translation science team or you are in education, but this framework is applicable to any team you work in. I've also got the similar concept actually in a two pictorial way. So one which I have already shown you in my earlier slide, but the second one which talks about the team effective model. And again, these are the similarity found from several models which are already listed in the literature. So they talk about the context, and in the context, the structure of team, climate of trust, performance in the reward system, very much applicable to what we are trying to do here in team science. And this is where I think the context plays an important role. The performance in the reward system, I think, is important for team science because we do have several of junior faculty. The promotion and tenure guidelines sometimes does not allow some, and I think we can probably talk this a little bit in depth when we meet in person to go over some of this exercise. The task identity, autonomy, skill, variety is another one which will play a very important role in team effectiveness, because whenever we work in team science, the interdependence increases. So that may just diminish one's ability to dominate things, because right now we probably have to take a different role as our interdependent dependency is increasing. The process also has to be defined, and common purpose, specific goal, team efficacy, conflict level. So all these has to be discussed way in advance for one to be an effective team. The composition also matters, and I'll come back to this slide as we discuss a little bit more in detail with some of the evidence base which has come from the science of team science. So ability of the member, the personality type, allocating role, diversity, flexibility. So a lot of this interpersonal relationship and individual factor also contribute a lot when the team is effective or not. So this slide basically is summarizing what the literature is showing about the effective team building model. So why team fails? And again, some of like the next two slides I have are also from the literature. So why do team fail? So they're actually highlighting three very, very important in the triangle. So there is a leadership, capability, and focus. So these are the three prime things which can actually make the team fail. So in leadership, you have a lack of support, consistency or inconsistency of direction, vision, resources. And since we had only an hour, it was very difficult to pick and choose some of the slides, but there is tons of literature coming out, the influence of leadership on a functionality of the team level. So the leader may have a vision, but it does not trickle down to the team members. And that is a big red sign for the team to fail. One can definitely improve that strategy by increasing the communication, increasing the contact with the members, establishing a clear vision, because the leader may have the vision in the head, but not necessarily that is translated to the team members, and that probably would be pretty dangerous. A lot of time, and I think lately you may probably read this in the literature, which they talk about the managing the talent, or unleashing the talent. So in this case, the leader's role when they work in the team, they're pretty much like a coach. They are the one who inspire people to do above and beyond. It's not managing people. It's basically how can they figure out empower person to find their own strength. And I think that's a very unique talent the leader has. And those are the things which basically highlights or which will really help the team build. Capability is another issue which the team can fail. Lack of critical skill set, knowledge, ongoing learning and development. So I think a lot of time these are people, smart people are put in this team. And many times the critical skill set, as the science is evolving, we all have to learn new things. Maybe in my own area of content, I'm a microbiologist, but still things keep changing. And I think once getting the terminal degree, I have not probably reached the stage which I can say I know it all, because you are basically learning, continuously learning. So improvement strategy. So you really have to, the team, you have to have a staff, the team, and I'm sorry, I can see my typo here, but staff the team with the right people. And another book I would recommend is Putting the Right People on the Bus, and there is the Good to Great is another nice book. Probably would be very nice also thing when we are trying to study the team science. Provide appropriate education training, establishing individual development plan, regularly assess the team effectiveness. So those are the another improvement strategy given by the literature. The lack of clarity about the team's purpose, and that is the, again, team's purpose, role, strategy, goals, those are the things which, sometimes team members are not probably brought together. And that will be also probably helping contribute towards the team failure. So establishing the clarity team mission, ensure open channel for communication, information, and clarify team members' role, establish regular team meetings. So these are very, very important when the team is ready to build. And I think I have, next slide, I'm also going to share a couple of model which has been already used in team science about really understanding how the team is built. So it's not just asking people to just be together to work on a task, but how do you actually systematically build the team? The one which is used in literature, and that is Bruce Tuckman, who was a psychologist, and Bruce Tuckman was the psychologist. He basically gave forming, storming, norming, and performing model of the team building. And I think this has also been quoted a lot of in the team science or science of team science literature, which they say this is very important when the team is building. So the forming stage is the stage when you have a key scientific idea or the hypotheses are formulated, and the potential participant are in the team or the collaboration are actually identified in the forming stage. And if they are invited, often period to a great intellectual excitement mixed with attention to formal organizing. So here where the people are included based on the idea or the concept which they think the scientific team can be formed. So once the group is put together, then the next is the next will be involved, it will move to a storming phase. And as the name suggests, it's definitely a storming phase because this is where which it will take the shape for the team. And as hard it is, but in reality, there are several teams cannot even move past this phase, is the storming phase. So what is the role of this phase? Basically in this phase, you will include to develop a shared vision, implement process for managing conflict, while also you will try to create a safe environment or a safe space. You have to basically define roles, responsibility, and this is the reason I think sometimes the team can never pass through. You're trying to make this as a very nice scientific unit, and you will also try to tap into wariness about diminished autonomy as well as trigger disagreement. So here where the people have this turf battle, and I think you probably see this also in your own career and life, that there is also struggle between MD, PhD. Among MD, there are specialty fighting over there, but this is all about turf battle. But the team science is actually trying to remove those walls and really trying to break those silos to bring this in reality that each one of us has something important to contribute. So one of the most important tasks here the leader will actually play, and the role of the leader is very, very important here, because they can actually, ironically, they will share the turf battle. The leader can actually help share the goal and the responsibility in this phase. The good part about this phase that it does not require the sort of a in sense or harmony or of consensus. It just requires a very nice atmosphere or an environment where people can actually flourish and they feel part of the group. So after this is formed, next it moves to the norming phase. During this phase, there is a team member will begin to work together effectively, efficiently, and develop a trust comfort with one another, and then they can rely on each other and then perform. At the performing stage, basically it's complete harmony. Together they work seamlessly. And this is the Bruce Tuckman's pyramid has been used, and this also applies very well to team science. I have another model, but it's also Dyer's team building model, and that's the one right now, I think, in our class as I teach team science. I'm reviewing that to see, but that also brings like the model of 4 C's. It says change, context, composition, competency. And in his 4 C model, the change is that team also needs to have an ability, they should have an ability to adapt. So they need to really monitor the performance, make changes needed. And sometimes this is where the people have lots of issue, adaptability. The context is the need of teamwork, type of team needed, system that supports the need. Teamwork has to be thoroughly vetted and formulated. You also have to look at the composition, your member of your, since it's a diverse team, you really definitely have to look at their skill, experience, what are the motivator for the team to be part of the team is important, because one thing is about people have to really love science, and more than science, they have to love working with others, and that will make science a lot more fun. The competency is the team ability to solve problem, communicate, make decision, and manage conflict. So they really need to promote the disagreement, but at the same time, that's a different thing, because in science, we do have to have there's a difference between a discussion and debate, and one needs to really manage that very differently. The managing conflict is another skill set, which I think some of us are not trained, and that is actually very, very important when you're really trying to build the team. So next couple of slides, I'm going to actually directly talk about the team science, or the science of team science. And that is the one which I think come up with the next slide. So we know that the team science is all about collaboration. You probably saw the a couple of slides ahead, but there are several impetus or factor which inhibits collaboration. So there are, and if you really look at the literature, you have interpersonal context, the context of participation, university, department, research lab, etc. And then you also have institutional distinctiveness, which they'll stress the disciplinary competency versus out-of-the-box thinking. So there are lots of things under this slide, but I think what I'm going to highlight is the interpersonal context. So a couple of, in this, again, I've highlighted the reference. This came out in 2012, where they had actually studied several, the science of team science field had studied several teams which are considered functional. And I also wanted to just highlight that whenever you say high performing or effective, it's not in the term of the end product of what they delivered, but I think how cohesiveness is the team is considered the effective team or the successful team. So this is after researching and interviewing several people who work in the team science, they identified the characteristic. And they are again, open, clear communication, trust, passion, skill learning, shared goal, effective leadership, self and team awareness. So those are the things highlighted. Some of this we may not have time to discuss in depth, but I'm going to highlight few which is probably very uncomfortable for scientists to discuss. So as leadership one, which we have already discussed, so self-awareness and team awareness, and the trust are the two which I would like to focus. So the reason it is difficult, because we as in scientists, the area of self-awareness, self-realization, and those kind of things are very touchy-feely, or they're very soft-headed. And we really, as a scientist, want to focus just on the scientific problem. We really don't have time to study interpersonal skill and learn about others. But this is where I think the researcher, they have shown that that's the one which basically can play a very important role. So self-awareness can provide a foundation not only for the self-control in a wide variety of situations, but also self-control can also help one self-regulate his or her reaction when they're working in teams. And here, one more book I would like to throw, that is Emotional Intelligence 2.0. If you haven't done that, maybe you may want to review the book. But basically, it is also your own communication style. How do you approach a problem? How do you manage a conflict? What personality types? I think people have done those MBTI and also done the 360. But basically, that awareness is not how others are working, but how do you work in a team when somebody is having a crisis? How do you handle that? So it all comes back to self-management and self-awareness. And the Emotional Intelligence 2.0 can actually show you about your personal competence, what I see, what I do, self-awareness to self-management, and to social awareness and relationship management. And I think this basically plays a very, very important role in team science. The content expertise alone is not going to make you functional member or the participant in team science, but your emotional quotient or EQI is actually going to top that. And this thing which I want to show you about the self-awareness and team awareness is important. The second thing which I wanted to highlight is the teams of the trust. So in science, confidence in another intention, commitment is just one aspect of trust. And this is another area which we feel very, not very comfortable because again, we are all scientists and we really don't have time. As long as you're doing your job right, we don't have to worry about others. But I wanted to highlight there are three things why it's important to team science. So there is an identity-based trust, calculus-based trust, and a competence-based trust. So identity-based trust is at the level trust exists because the party effectively understand each other, they appreciate each other, and they've already developed that sort of a interpersonal relationship. So they value their opinion, they have a mutual understanding they develop. Then they have a calculus-based trust, which is in day-to-day life, you probably see this, and that's something we actually, that has nothing to do with the relationship development, but your understanding of other person's behaviors. So for example, that if you have certain deadline or fulfill certain expectations, so people have to do in a timely manner, over the time, you may realize that this person will never follow through or never come back in time, never return your email, never. So those kind of things can actually start building it up. And that's a calculus-based trust. It does not depend on a deep personal understanding, but it can definitely erode over the time. If it is done very well, you can actually develop, but it can, if not, then it can actually break in a very different way. Competence-based trust is built in a confidence base. So how confident are you with your team member? So if you have a PI saying that my technician is fantastic and does a great job, are you confident about that? And sometimes those kind of trust can also influence the team very differently. So we have in our capability and the skill base, and sometimes I think that can also trip the card. So even if there are no question about an individual, but if it's not about the individual's character, but it is impossible to work effectively if you think that the colleague whose work itself is not trusted. And you can't be working and producing result if you think the colleague's work which is not trustworthy. So this is the reason I wanted to highlight value and understanding of the trust. And last few slides, I would actually like to share again from the paper, which they are having the collaborative research agreement. And I think when we meet in face-to-face meetings, some of these we will have to practice this out. So they have like a collaborative research agreement. So do you have categories are goals of collaboration? What is your project? And do you really discuss who will do that? How will you assign responsibility, accountability? And major thing which I see in a team science is the authorship credit. So who criteria, attribution, public comment, media, IP, company if it goes. So all that has to be really do a lot earlier than before the team is in the forming stage. Contingency, communicating, what if, the rules of engagement. So I think I've just summarizing this in table, which is actually taken from the paper, which is the reference is listed here. But those things become pretty important when you're trying to practice team science. This is the conceptual framework of team effectiveness, and that's actually taken from the National Academy of Science book, which was published on team science in 2015. And some of these we've already discussed. Unfortunately, it looks like I'm running out of time, so I may not have time to go over each of the tasks. I also wanted to share that NIH has committed several commitments. They've gone the toolkit, Team Science Toolkit is a very wonderful, phenomenal resource. The website provides user support, engaged study team-based research, and a lot more. And there are several other sites which you probably could use it, and they are the link listed here. I think I've probably taken a little bit of too much time, but I wanted to, on behalf of West Virginia CTSI Professional Development Corps, I would really like to thank you for participating in our first Team Science webinar and spending this 1 hour on Friday afternoon virtually. So if you have any question, and I don't know whether we have time, but if you have any question, please use the chat icon. And if the time doesn't permit, we can probably still work together. I also wanted to highlight, as Julie has mentioned, that understanding and improving team dynamics will be our next session, virtual session. We will offer the session on December 8th on a Team Science webinar. Once again, thank you for your time. And here, West Virginia CTSI Professional Development Corps, I think we've really formed into a team, and I'm hoping that we can serve together very well for those researchers who are involved in team science. Thank you.